Greetings to all members of this community. I am Ondasan Worku. If you are joining us for the first time, welcome to a platform dedicated to fostering a deep understanding of the natural sciences. Our content is specifically curated for students in grade 9 through grade 12, as well as educators and parents seeking quality academic resources. I invite you to subscribe and become part of our growing scholarly community. In our previous session, we explored the fundamental operations of set theory, union, intersection, complement, and difference. If you haven't viewed that lecture yet, I highly recommend doing so to ensure a solid foundations for today's lesson. Today, we will advance our discussion by covering set notation, subsets, and Venn diagrams. Let's begin. Set notation, subsets, and Venn diagrams with visual examples from science. Set notation, subsets, and Venn diagrams form the foundational building blocks of set theory, a branch of mathematics that deals with collection of objects. These concepts are essential for organizing and analyzing data in various fields, including science, where they help in categorizing and visualizing a relationship between groups. A set is a well-defined collection of distinct objects called elements, which can be anything: numbers, letters, objects, or even other sets. In science, we often group things with shared characteristics. A set is simply a collection of these distinct objects, which we call elements. We use curly brackets to list elements. Example, if we have a set of noble gases, we may write G is equals to helium, neon, and argon. The next idea is an empty set, also called a null set or void set, is a set that contains no elements at all. Think of it like an empty bag. The bag itself exists, but there is nothing inside of it. There are two common ways to write the empty set: the symbol of empty set, the Greek letter phi, or the brackets, empty curly braces. Common pitfall: the empty set is not the same as the set 0. The set 0 is a singleton set because it contains one thing, the number 0. Empty set contains absolutely nothing. The third topic is a subset. A subset is a smaller collection of elements taken from a larger set. A is a subset of B means everything in A lives inside B. Nothing in A is outside in B. A is a subset of B means every member of set A is also a member of set B, because everything in A can be found inside B. In short, A is a subset of B means A is completely inside B. In symbols, A is a subset of B means if X is an element of A, then X is an element of B. Here are 5 clear examples. The first example, fruits. Set A, apple, banana. Set B, apple, banana, orange, and mango. A is a subset of B because every fruit in A is also in B. Example 2, numbers. The first set, even numbers. 2, 4, 6, 8. The second set, whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Even number is a subset of whole numbers. The third examples, pets in a house. The first set, cat and dog. The second set, cat, dog, fish, parrot, and hamster. A is a subset of B. Also, cat is a subset of A, dog is a subset of A, empty set is a subset of A, because empty set is a subset of every set. Example 4, colors of the Ethiopian flag. Set A, green, yellow, red. Set B, green, yellow, red, blue, and white. A is a subset of B because these are exactly the three colors used in the Ethiopian flag. The last example, or example 5, days you have class. Set A, or school days, Monday, Tuesday, Wednesday, Thursday, and Friday. The second set, or set weekdays, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. School days is a subset of weekdays. A proper subset is a specific type of subset. To understand it, we first have to recall that for any set B, a subset A is just any collection where every element of A is also in B. A proper subset adds one strict rule. The two sets cannot be equal. In other words, set B must have at least one element that is not in set A. So A is a proper subset of B means every element of A is also in B and A is smaller than B, which means A cannot have everything that B has. In other words, A is strictly inside B. There is at least one element or one thing in B that is not in A. Symbol A is a proper subset of B. Most school books today use this sign or this symbol because clearly say proper subsets. Quick comparison. A is a subset of B means can be equal or smaller. A is a proper subset of B means must be smaller and cannot be equal. Here are 5 clear examples about proper subsets. The first example, fruits. Set A, apple, banana. Set B, apple, banana, mango, and orange. A is a proper subset of B is true because A is smaller. Mango and orange are extra. The second example, even numbers. Set A, 2, 4, 6. Set B, 0, 2, 4, 6, 8, 10. Or all even numbers. A is a proper subset of B is true because B has many more even numbers like 0, 8, and 10. The third example, your classroom. Set A, you and your best friend. Set B, all students in your class. A is a proper subset of B is true because your class has many more students. The fourth example, Ethiopian flag colors. Set A, green, yellow. Set B, green, yellow, red. A is a proper subset of B is true because red is in B but not in A or missing from A. The last example or the fifth example, prime numbers less than 10. Set A, 2, 3, 5. Set B, 2, 3, 5, 7. A is a proper subset of B is true because 7 is in B but not in A. The last topic is what is a Venn diagram. A Venn diagram is a picture made of overlapping circles or other shapes that helps us show relationships between two or more sets or groups of things. It makes it very easy to see what things are only in one set, what things are common or shared between sets, what things are not in any set. The most common types are 2-circle Venn diagram and 3-circle Venn diagram. Key parts students should remember. Each circle is equals to one set. Overlap is equals to things that belong to both or all sets. Outside circles but inside the rectangle is equals to things in none of the sets or sometimes shown. Here are 4 clear examples. The first example, fruits and vegetables. Set A, fruits. Set B, vegetables. Only in fruits, apple, banana, mango. Only in vegetables, carrots, cabbage, potato. In both or overlap, tomato. Many people argue if it is fruits or vegetable. The second example, numbers, even and multiples of 3. Set A, even numbers, up to 12. 2, 4, 6, 8, 10 and 12. Set B, multiples of 3, up to 12. 3, 6, 9 and 12. Only even 2, 4, 8 and 10. Only multiples of 3, 3 and 9. Both or overlap 6 and 12. The third examples, a student's hobby. Set A, students who like football. Set B, students who like music. Set C, students who like drawing. Only football, some boys. Only music, some girls. Football plus music, no drawing. Football plus drawing, no music. Music plus drawing, no football. All three, very few talented students. None students who like reading or gaming instead. The last example, proper subset shown in Venn diagram, which is represented by two circles, one inside another. Set A, cat, dog, pets you have or in your house. Set B, cat, dog, bird, fish, rabbits, all possible pets, which is expressed by in Venn diagram. Circle A is completely inside circle B. No overlap outside A. Shows A is a proper subset of B. Nothing in A is outside B.